Hello and welcome back. I know I said I was going to go over while loops and arrays. However, I decided to go over just basically loops in this video. In the next video, you'll see why once we get there. Anyway, so to start off, to create a while loop, and what our while loop, what our while loop is going to do is going to create sort of like a bunch of ellipses side by side next to each other. So to do this, I'm going to say int, oops, what happened? There we go. Int I equals 0. This is our index, sort of. This variable will be our indicator of how far we are in the loop. So while I is less than 20, run whatever code's inside of here. Now, if this isn't obvious, what's basically going on is that a while loop runs until this condition becomes false. So as long as I is less than 20, all the code that we put in here is going to continuously repeat before it exits the loop. So ellipse, and I'll say I times 20. That way it looks like the ellipses are right next to each other. And 20 by 20 by 20. There we go. And, oh yeah, this won't run properly. The reason is because I need to put I gets I plus 1 inside of the loop. This way, our I value increments so that when the loop runs again, it'll be like, oh, start at 0, run the loop, start at 1, run again, and it'll continuously do that all the way until it reaches 20, and then it won't run at 20. So, here we go. We have 20 ellipses, starting at the value 0. The I starts at the value 0 and goes all the way to 19. So when we get into arrays, you're going to notice that the first index is actually called 0, not 1. And it's basically for reasons very similar to this. It has to do with an offset of addressing, and don't worry about that. I'll get into that in the next video. Just kind of know that it's coming. Anyway, okay, so we have a bunch of ellipses right next to each other. Well, what can we do with this? Well, we can something like this, for example. Int y equals, I don't know, 20. So that gets y. And then every frame, y gets y plus 1. There we go. I'm missing something. Oh yeah, y is a local variable to this function. So what's happening here, why this isn't working, why the animation isn't running, is because when our draw function loops again, it recreates the value y at location 20. So yeah, sure, it'll become 21 down here, but then it's recreated inside of this function and it becomes 20 once more. So to get around this, there's two ways. We can either make this a global, which would fix it. See, like that. Or we can make this static, which means that the variable y becomes persistent between each call. Oh wait, does that not work in Java? Illegal modifier for parameter y, only final is permitted. Okay, I may have missed something. I'm sorry about that. I didn't mean to deceive you there. That'll be more C syntax, I guess, later on when we get to that. So yeah, please disregard that. Anyway, so now we have animation. All the balls are moving right next to each other towards the bottom. If we wanted them all to bounce, the thing is that they would all either bounce together or not at all. This is where in the next tutorial when we go over arrays, you'll start to be able to have it to where each one acts individually on its own. But for now, I want to make sure that we get loops down so that way we're able to iterate over this array so that it works better. Anyway, now a shorter way of doing this would be using something called a for loop, which is a lot like a while loop, except it's like a shortcut, basically. So to start, you would type something like for int I equals 0. So we're declaring a variable I inside of the for loop within the parentheses. I is less than 20. I gets I plus 1 without the semicolon there, and then the body. So inside of here, we create our ellipse at I times 20, which I is usually referring to index. That's why we call it I for things like loops. It's just kind of what programmers usually do. So 20 there, 20, 20. Oh, my mistake. That should be a Y. There we go. And as you'll notice, it's doing the exact same thing. If I were to change this value down to 10, we would only have 10 balls instead of 20. Starting from 1, or not 1, starting from 0 and going to 9. So, with this, there is something else I want to go over before in this video, which is there is a shortcut to increment a variable. So instead of saying like I gets I plus 1, we can just say, or not I, I'm sorry, y gets y plus 1, we can just say y plus plus. Oops, lowercase, my bad. If we do this, you'll notice the exact same thing is happening. So all this plus plus means is give y the old value plus 1, just increment it. That's the definition of what incrementing is. Now this arises from somewhat from a CPU instruction which is called increment, and what it does is that it increments a register instead of adding the value of 1 to it. It's just a different opcode. It's partially related to that, not entirely, but yeah. So partially because of that we have this. And besides that, incrementing variables is actually extremely common, especially in while loops and for loops. Especially when you're iterating over data, which, believe it or not, is going to be extremely common when you're programming. So when you see something like this, now you know that it means increment the variable, which give it its old value plus 1. So if we replace this with I++, it should still work. Which, in fact, if you look at for loops from other people's code, oftentimes they're going to have that I++ there. So if you see that, now you know what it means. And because we had to go into, or because we're going into for loops, and I highly encourage you to look at other people's code, you're going to see this a lot, and so so that way you know what you're doing. That's basically it for this video. Next video, we are going to go over arrays and how to give our ellipses their own functionality. I am going to bring back some code for how the ball collides up and down with the window. I'll probably wrap that into function. Remember, we used that in the last video. So the next video is sort of going to give some modularity and go over everything we've basically learned so far. So I hope to see you then, and take care.